Hello everyone, my name is Sarah, and today we are going to learn about 7 Earth-sized planets which were found orbiting a super cool dwarf star. So there's a lot of stuff happening on Earth these days, a lot of crazy things. We've got the pandemic, we have the 2020 US presidential election. It's very stressful. Sometimes I imagine it'd be really nice to escape. So when I heard about this, I was actually really intrigued and excited. So hopefully you guys will also find this article to be interesting because I wrote it. So at least pretend like you like it. It'll make me really happy. The NASA Spitzer Space Telescope has revealed a batch of 7 Earth-sized planets within the TRAPPIST-1 planetary system. 3 are located in the habitable zone, where rocky planets are most likely to have liquid water. So our planetary system is called the solar system, right? Because it revolves around the sun, which in Latin is sol, so solar system. But there are also lots of other planetary systems in our galaxy and also in other galaxies. So the NASA Spitzer Space Telescope, which is a huge telescope that can look super far into space, it found that there are 7 Earth-sized planets in the TRAPPIST-1 planetary system. If, in theory, we wanted to leave planet Earth and go somewhere else, it's really important that the mass of the planet is roughly equivalent to that of Earth. Well, why? Because of gravity. So if you or I were to go to a planet that is much bigger or much smaller than planet Earth, our body could not really know how to respond, right? Because our body and all the cells and the atoms in our body, they've evolved to match the gravitational pull of the Earth. So if I were to go to, say, the moon, I'd be able to jump really high. Maybe that wouldn't be so bad, but if you or I were to go to Jupiter, per se. Jupiter is actually not a rocky planet, it's a gaseous planet. But in theory, if we were to go to Jupiter, because Jupiter is so much more massive, it has such a much larger mass, it's very heavy, so we would literally get like squished like this. Our body would just collapse like this. So that's not ideal. We don't want that. So that's why it's important that if we're looking for a new planet that we can live on, that the size or the mass is roughly similar to planet Earth. So this is really good news, right? There are 7 Earth-sized planets in the TRAPPIST-1 planetary system. So, maybe this could be a good option. So out of those 7 Earth-sized planets, 3 are located in the habitable zone, where rocky planets are most likely to have liquid water. So one of the most important things for human survival and also the survival of pretty much every species on this planet is water. So if we were to go to another planet, we would absolutely need that planet to have a supply of liquid water. So we can drink it, so we can go into our bodies, so we can be hydrated and healthy. So there are 7 planets that are the same size as the Earth in the TRAPPIST-1 planetary system, but out of those, only 3 are located in the habitable zone, where there is more likely to be liquid water. And the way that they can calculate this is by determining the heat given off by the star at the center of this planetary system, and also the distance between. So how much heat is transferred from the star to the surface of the planet. And liquid water can exist between 0 degrees Celsius and 100 degrees Celsius. If it's hotter than that, it boils, it turns into gas. If it's colder than that, it freezes and it turns into ice. And either way, we can't really use it if it's in either of those forms. We need it to be liquid for us to be able to use it. So this is super important. This discovery could be a significant piece in the puzzle of finding habitable environments, places that are conducive to life, said Thomas Zurbuchen, an associate administrator at NASA. So, okay, quick question. Do you guys believe in aliens? I think I do believe in aliens. I'm not sure if they're life forms that we would be able to recognize, because maybe they exist in habitats or biospheres that are totally different from humans and animals and plants that we see on planet Earth. But I'm pretty sure if there's life on this planet, it's gonna exist somewhere else, right? So this scientist, Thomas Zurbuchen, who works at NASA, he's really excited because this discovery of the 7 potentially habitable planets, it could mean that we're getting closer and closer to the discovery of extraterrestrial life. So extraterrestrial, that means outside of Earth. Extra, outside, terra, Earth. So extraterrestrial life. So if you believe in aliens, then this is a potentially really interesting and exciting discovery. Because, as we just said, the 7 planets in the Terra 1 planetary system, and especially the 3 that are located in the band where liquid water can exist, they are more conducive to life. So conducive, that means to make something more possible, to make easier, etc. So you can also use it in another context, like certain classes or environments are more conducive to learning. So I find that providing a visual aid, such as this PowerPoint, or using facial expressions and hand gestures, that creates an environment that is more conducive to learning English. So I hope that all of you agree, because I worked really hard on these presentations. And then, okay, we saw this word habitable also on the previous slide. So the 3 planets are located in the habitable zone. So what does that mean exactly? Well, let's break it down into its parts. So habitable. So what's habit? Well, in Korean, I guess you could translate it as 습관. And then able means possible, right? So it's possible to make a habit? 습관을 가능하게 만든 것일까요? 그거 아니죠. Because habit, in this situation, it actually means to inhabit, which means to live somewhere or to survive and thrive somewhere. So you can think of this habitable, it's actually more similar to the word habitat. So for instance, the habitat of a giant panda would be the bamboo forests of China, or the habitat of a giraffe would be the savannas in Africa. So a habitat for humans, right now, it's only planet Earth, but maybe if we look into other planets that are similar to planet Earth, they're habitable for humans, we might be able to find extraterrestrial life or aliens, or maybe we could even move there ourselves. So some people are really excited about maybe discovering aliens, but people like me are thinking about this a little bit differently. However, some are more interested in the planet's potential to host human life than in unknown life forms that may exist on the planet's surface. So this word potential, in Korean, I think you would say 잠재 or 잠재력. So potential, it means there's a possibility of doing something or being something. So these planets could potentially, we don't know for sure, but maybe it's possible they could host human life. So I guess I'm really interested in aliens too, but I think personally I'm more excited about the potential for people like me and you to go to these planets and perhaps live there. Unlike our solar system, the star at the center of the TRAPPIST-1 planetary system is a supercool dwarf star, which is smaller, redder, and cooler than the sun. So, like I said earlier, we also live in a planetary system called the solar system, because solar, that means sun, from the Latin root sol. So there are actually tons of other planetary systems that exist both in our galaxy, the Milky Way, and also in other galaxies. So the TRAPPIST-1 planetary system, it's also a planetary system, but instead of having the sun, like the solar system, they have a super cool dwarf star. So let's break this down. I know this word looks really difficult, but actually if you just look at the words, it's pretty easy to tell what exactly it means. So, super cool. What does that mean? Well, it means extremely cold, right? So, you guys probably know that the surface of the sun in our solar system, or our planetary system, is extremely hot. It's so hot that you can't touch it, you can't go near it, you would just burst into flames, and yeah, it'd be really painful and horrible. But because planet Earth is so far away from the sun, we can enjoy the warmth and the light of the sun without it, burning us into fire. But the star at the center of TRAPPIST-1 is a super cool dwarf star. So it's super cool, which means it's much colder than our sun. That doesn't mean it's cold. That doesn't mean you can touch it. It's still very, very hot, and you can still burn yourself, and probably you would die. But yeah, so yeah, it's kind of like the sun, but it's colder. Okay, well, what else? It's a super cool dwarf star. So what is a dwarf? A dwarf, it's so that's a creature in a lot of Western mythology, or Shinhwa. I'm not sure if this concept exists in Korean mythology, but basically it means a really tiny little person. So for instance, if you've ever seen Snow White and the Seven Dwarfs, you'll know that the princess, 백설공주, or Snow White, she has 7 little men that follow her around. So those men, in English, we would call dwarfs. So when you think of a super cool dwarf star, probably means a star that is much colder than our sun and also much smaller. So it makes a lot of sense when we look at the next part of the sentence. So unlike our solar system, the star at the center of TRAPPIST-1 is a super cool dwarf star, which is smaller, hence the dwarf, redder, and cooler, since the super cool than the sun. So if you look at flames, I believe, correct me if I'm wrong, so red, it's hot, and then orange, yellow, white, and blue. So it goes from through like different colors, right? So if it's red, while our sun is yellow or orange, that means it's cooler than our sun. So learning lots of fun space facts today. Because the star is so cool, 2,430 degrees Celsius, compared to our sun's 5,505 degrees Celsius, relatively proximate planets can maintain supplies of liquid water. All 7 exoplanets are located closer to TRAPPIST-1 than Mercury is to our sun. So this is a bit of a long sentence with parentheses, so let me explain. Okay, so we just discussed that TRAPPIST-1, which is the star at the center of that planetary system, it's a super cool dwarf star, right? So because the star is so cool, and in this case that means over 2,400 degrees, it's still extremely hot. I mean, none of you will probably ever get to go to this spot, but if you do, don't touch it, it'll burn you, you'll die. So the star is cool, it's 2,400 degrees, which compared to our sun's 5,505 degrees, both extremely hot, but one definitely hotter than the other. Relatively proximate planets can maintain supplies of liquid water. So like we just said, when water heats up to over 100 degrees Celsius, it evaporates and it turns into gas, right? So if our planet was a little bit closer to the sun, it'd be really hard to maintain supplies of water because it would just evaporate off the surface of our planet. So if you look at Mercury and Venus, which are 2 planets that are closer to the sun than the Earth, it's very, very hard to find evidence of liquid water on their surface because they're so close to the sun that it just evaporates the second that it exists. So yeah, their atmosphere, it doesn't have so much water in it. It has a lot of other stuff which is extremely poisonous to humans, so you definitely don't want to live there. It's not very pleasant. So if you think about it, so we just said that the star at the center of TRAPPIST-1, it's a super cool dwarf star, right? But because it's so much colder than our sun, that means that planets that are more proximate, that means closer to that star, they can maintain supplies of liquid water because this is less hot, so you can be closer and still have liquid water. So, and we know this because all 7 exoplanets are closer to TRAPPIST-1 than Mercury is to our sun. So, like I just said, Mercury is so close to the sun in our solar system that no water can exist on its surface because it evaporates and turns into gas immediately. However, despite the fact that all 7 exoplanets, that means planets from outside our solar system or planetary system, so exo, that means outside, all 7 exoplanets, even though they're located closer to TRAPPIST-1, the Supercool dwarf star, they can still have liquid water, even though they're closer to the star than Mercury is to our sun. So through that, you can see there's a definite difference, right? While Earth is in the grips of a series of political and epidemiological crises, escape to another galaxy might seem like an attractive option. However, life in the TRAPPIST-1 planetary system might not be as pleasant as it seems. So, this is very disappointing news to me. I just want to escape, just want to go somewhere else, and then come back after the world has just stopped being crazy and insane. So, like I just said, these planets, they have water, they're similar in mass to the Earth, they have a sun, it's kind of like our sun, but it's also a little bit different. So this all sounds really good, right? Especially right now when we're in the grips, we're going through so many political crises and also the epidemiological crisis of COVID-19. It's like, escape to another galaxy seems like a nice option. However, life in TRAPPIST-1 might not be as pleasant as it seems. So, we have been talking about the similarities that the planets or the exoplanets in TRAPPIST-1 have to planet Earth. But I guess there are some pretty important differences that might make life for you and me difficult in TRAPPIST-1. Evidence suggests that the planets are tidally locked, meaning that the same side of the planet is always facing the star. This introduces severe weather conditions, such as strong winds and extreme temperature changes. So this word, tidally locked. So if we think about the moon, so the moon, it revolves around the Earth, and so at night we can see it. During the day, we can't see it because it's on the other side of the planet, right? So, and the moon also controls the tides, right? It makes the water go towards the shore and then away from the shore, which is actually, it's pretty amazing when you think about it. But, so if you think about the moon, actually, no matter where you are standing on planet Earth, you will always see the same side of the moon. So there's a side of the moon that we can see, the one that you can see in photographs, and that if you step outside, it's what you'll see. But then there's also another side of the moon. It's completely dark all the time unless it happens to be facing the sun, and in that case, it would be a solar eclipse. So if you think about it, usually during the day, it's much warmer, right? And then at night, it gets colder. And that's because we're not getting the rays of the sun giving us warmth. So usually, at any given time on planet Earth, the side where it's day is going to be warmer than the side where it's night, right? So it's the same thing with exoplanets and also the moon, which are tidally locked. But if you think about it, so what causes wind exactly? Well, cold air sinks and hot air rises, right? So when we have different temperatures of wind, usually, so like they're always trying to find equilibrium. So the hot air is always trying to rise, the cold air is always trying to go down, and that's why we get wind. So usually when there's an extreme temperature change, for instance, usually there'll be a little bit more wind, right? So if you think about it, these planets, one side is always facing the star, and the other side is not facing it. So the air on the surface of the planet is constantly trying to find equilibrium. The cold air is constantly going down, the hot air is constantly going up, and because one side of the planet never ever sees the light of day, ever, so it's extremely, extremely cold over there. And then the other side, it's constantly 24 hours a day, or however long a day is on those planets, it's constantly getting the light and the heat of the sun. So it would cause extreme winds, which would make it very difficult and probably unpleasant for you and me to live on those planets. Additionally, TRAPPIST-1 is located 40 light years away, a neighborly jaunt in the cosmic sense, but a distance that would take 1,488,000 years for humans to travel using the fastest possible technology. Such a shame. So TRAPPIST-1, it's in a different planetary system. To my knowledge, I believe it is still located inside of the Milky Way, which is our galaxy. However, outer space is so just immense. We can't even imagine it. So TRAPPIST-1, it's 40 light years away. 1 light year is the distance that a particle or a ray of light can travel in 1 year. And that's the fastest that you can go in the entire universe. You cannot go faster than the speed of light, or at least that's what scientists think right now. So 40 light years away. If you or I were to somehow ride on top of a ray of light or a quangsan, it would still take us 40 years to travel from planet Earth to the TRAPPIST-1 planetary system. So in the grand scheme of things, when you think about how huge the universe is, this actually isn't that far. It's only 40 light years away, which is a neighborly jaunt in the cosmic sense. So cosmic, that refers to outer space, things that are out of this world, off of planet Earth. So, like I just said, if you think about it in terms of the universe, it's not actually that far. So you could say it's kind of, relatively, it's kind of like going to your neighbor's house. It's like taking a walk or a jaunt over to your neighbor's house. Not that far. But you and I, we don't live in universe years. We live in human years. And usually a human lifespan is somewhere between 60 to 100 years, right? Well, even if we use the fastest possible technology, the best rocket ships that we have available to us at this moment, it would still take 1,488,000 years for you or me to go from Earth all the way to TRAPPIST-1 planetary system. So probably we would not survive. We would certainly not survive that long. And I mean, in that amount of time, probably most of the problems that we're dealing with on planet Earth, they would probably go away by then, right? So I guess in the end, it's better for us to just stay put, stay on planet Earth, and learn how to deal with our problems, be they political, be they environmental, or be they epidemiological. All right, well, this is a super fun article to write and also to explain. I hope that it was also fun for you to listen to. So we make these videos every week, and I look forward to seeing you again in next week's video. All right, everybody have a wonderful day, and I will see you next week. Bye.